Don.
I'm Rafi.
I'm Lion.
And we're On-Key. We were a group with the intent of building a piano keyboard. Our main objectives, as we talked about in a presentation we gave on December 4th, were to build off of original sustaining code and incorporate new functions. This original code we found from a online source. The online source author had created a contraption where he had hardwired physical keys to an FPGA and also hardwired a potentiometer. Each of these physical keys was programmed to output a different note from a speaker from the FPGA. The potentiometer was programmed to change the pitch of each key. So when taking this code, our main objective was to take this code and implement new functionalities, including a keyboard input and memory allocation. By memory allocation, we're referring to people being able to play notes on their keyboard and be able to store those notes. Unfortunately, we misallocated some of the time we were given for this project gravely, really, and we weren't able to successfully complete these functionalities. However, if you check our GitHub right now, you get to see our best latent attempts at incorporating both the keyboard and the memory functionality into this project. In this video, we'll talk a little bit about some of the code files we have on our GitHub repo and how they can be interpreted and why some of them might not be working right now. We originally, our top level function is our interface.v file, and Lion is going to pull it up on his Verilog Vivado right now. It's pulling it up right now.
Yes. So right now we go to the interface.
And it's okay, we can slice this part out right now. Yeah, do you want me to talk about this? I'll talk about this. Yep. This is our this is our interface.v file. It's our top level file, as I just mentioned, and it incorporates multiple inputs. It's taking in the most important input right here is our raw note input, which is essentially a set of 10 bits, one hot encoding, representing a series of 10 buttons and what state they are in. In the original code, the top level file was the controller, and a one hot encoding standard made sense for keys that could be easily glided upon smoothly. You could have two keys pressed down at once, let's say the leftmost key and the second and the third leftmost key. And in the one hot encoding of our raw note file, we would have 2 1s and 8 0s in the actual data representation of that what was happening in that very moment. That's I'd say one of the most important variables we have in our code right here. We also have our multiple modes of switching through our project, including our record and our mode selector. These, instead of implementing it as a finite state machine inside of our top level function, we decided it would be best to pass these down into further files, as we'll discuss later in the video. Right now, we have our buttons being debounced with our DBC.
Yeah. So right now we are using the FPGA buttons. So that's the reason we also apply the debouncers to the board. And regretfully, we didn't have the keyboard working, so we choose to use a switch on the FPGA board instead as our input to receive and register for the raw notes. So yeah, that's basically what we do with the raw notes. So next, I think we will discuss about how each function, each mode function, and we will describe detailedly about how module select and how the MIDI file incorporates in our interface.
Yes. So one last thing there's a lot to understand about our interface.v file, but some of the most important magic happens towards the end with these 3 files down here that I'm about to select. Mode select, USB mouse, and MIDI. USB mouse right now is a function that's not yet implemented. Rafi will talk about that in just a second. The other 2, mode select and MIDI, are actually taking that raw note input plus the pitch that's being assigned by our pitch shifter buttons and actually being able to output them to TX, which is a 1-bit output. You might be wondering why there's only a 1-bit output for a musical note, and that's because it's 1 bit being generated multiple times, and that code is actually already programmed into the original files that we received. Pass it off to Rafi, who's going to discuss
the mouse connector.
Yes.
I selected to that. Okay. So the mouse connector file originally was meant to connect to the keyboard or to the computer's mouse, which would allow the user to select the notes based on the positioning of the mouse. We attempted to change it to work for the keyboard, but sadly, we had some issues due to something called the PS2 interface. What that issue was that the data being sent from the keyboard to the computer and vice versa was extremely difficult to transfer. We could never quite get a way to actually get that data to transfer over consistently and to have it work, functionally with the code we wanted it to do. So because of that, currently in our Nexus control file, what we have is sections selected to the buttons on the FPGA instead of to the keyboard, which at least allowed for some theoretical functionality, even if the keyboard input wasn't physically working.
But with our mode selects, we specifically, let's look back at the mode select. It makes so much sense at the time. Okay. I mentioned that magical mode select file. The mode select I like to think of as somewhat of a mask. and a filter at the same time. It's taking in our raw note file and that mode inputs from, as of right now, the FPGA board. And depending on what that mode input file is, it will determine if the outputs note, the no longer raw note, should be the raw note itself, or if it should be a stored value, such as some pre-coded. Just keep doing it. All right. That mode select file that I talked about just a little bit earlier, that works a little bit like a filter. It takes in that raw note file and the current mode of our program and decides if the output note should either be that raw note itself or something else, namely a pre-coded music file from our original code or a recording that has been recorded by the user. That's what mode select does. Mode select, if we jump into that right here, interfaces with the MIDI, with the Mode select interfaces with our memory function right here, and it passes through the recording mode, the pitch shift, and the note, along with a few other important pieces of information. Once we jump into memory, we get to see immediately some parameters. These parameters right here are the defining one-hot encoding notes that make up our program. Right here.
Yes, we store those like 10 pre-encoded 10-hot-bit like keys into the ROM in such format, and yeah, and John will expand the next.
Yeah, and on lines 55 through 64, you see 10 different registers right there. This is what I'd call formally our attempt at making memory allocation for recorded music. Our idea was that we would have a counter that would start inside of our interface file, which if we go to our interface file right now, we see that we did initially have a counter right here, but weren't able to fully flesh it out. With this counter, we would have it go all the way up to 10, and once at 10 would end the recording mode of our program. This would ensure that after 10 notes, or in other words, 10 runs through our mode select function, we would have 10 notes saved in our 10 registers, and that music can be played back through these 10 registers. So our mode select file does interface with our memory file in two ways: one, writing to it, and reading from it, which is pretty nifty. Going back to our mode select file, and we see our mem file, and all the way back to our mem file, we see that we have the possibility to record many more notes. In fact, we see some pre-recorded music that has several hundred notes. We initially wanted to cap it at 10 because we were unsure if we could successfully implement it, and unfortunately, regretfully, we did not implement it. In addition to mode selects, I mentioned that we have our MIDI controller, and maybe Lion can talk about the MIDI controller.
Yes. MIDI part, there's two modules. The first one was a message encoder, which was responsible for dealing with the raw notes, which is also our input. We set the codes, we set the logic here to make sure it was like only go through this part. In this way, we could go through the logic here. This part of code is responsible of like encoding the raw notes into the right pitch, and it could be generating the bit stream also to the UART-TX, and the final TX is like a bit stream responding to time. It's using PWM module wave, and it's expected to generate the sum, but thankfully we didn't successfully implement it in our final code. But yes, that's basically how the medius one works. Yeah.
So to recap our endeavors so far, we came in with the intent of implementing that keyboard and memory. And although we weren't able to do those, we came out with something very valuable, and that was a better understanding of our original code. From the online source, we didn't necessarily understand how it worked at all. We didn't have precise instructions. The commenting was sparse and lacking. We changed all of that. If you go into our GitHub repo, you'll see that we've added many very informative comments that might even do a better job than what we're doing right now in this video. And in doing so, we realized that we wanted to simplify a few functionalities. Our record button, which we initially had as a two-way switch that would begin a recording and end a recording, we realized would be much better off being a one-time hit button. You hit record once, and it will record the next 10 notes and immediately shut off the recording functionality. And yeah, is this still recording? Yeah, it is still recording. In a project like this, where we build off extensively from former code, it can be hard to discern what we did and what was the original code. However, we have included the original code in the GitHub repo for reference, and our own code as a final folder so that anyone can compare the differences between the two. If one were to do so, they notice that our code it's much different than the original code in the sense that we've simplified it. It's much more formatted, we've added comments, and we've changed some of the logic, specifically removing many extraneous stuff, such as an ultrasound sensor, which was present in the original code. Yeah. So then I exit out saying, well, that was our project.
Should we say, okay, so as for my, we are coming to the contribution part. For my part, I was responsible for finding the project and do a little bit modifying, and John do help me a lot on making the code more concise and more readable throughout the way. And
steady footfalls in adding the memory functionality, or at least the attempts of the memory functionality, and abbreviating and shortening the code, essentially helping Lion very much in creating a much more abbreviated set of code. Our other groupmate Rafi, who couldn't be in this segment of As for our groupmate Rafi, who couldn't be in this segment of the video, he was very helpful in organizing our GitHub repo, making those markdown files, and adding some of the comments to our GitHub repository. Thank you for watching our video.